Hi John, without loss of generality, this week we are discussing intentional living. We meant to talk about this like a long time before about minimalism and intentional living and how they relate to each other. So I looked up a little bit what intentional living means and how and if I have implemented it already. And I looked around, it meant just how every decision should be aligned with our long-term vision about how we want our life to be. And the challenge of it is that since you have to make a lot of small decisions every day, you have to be intentional about each of your decisions and make sure it's aligned with your long-term goal in life or how you want your life to be. That reminds me of a few things that I have learned during my formal training in various disciplines first, and that reminds me of reinforcement learning. And reinforcement learning is mostly about finding a policy being how you make a decision given the state that you're in and a decision that you have to make or options, a bunch of decisions that you have to make. You have to evaluate the value of it to make sure that it optimizes your goal, and your goal in this term means the objective function. So when we talk about machine learning, reinforcement learning, we have to talk about the baseline. And another baseline that we can consider here is rule-based, being religion or whatever values that dictates you to do certain things, or even law that basically rules that you can just carry out your decision based on that. If something's illegal, you do not do that. You don't have to compute any value. You don't have to compute it against your objective function or anything like that. So why doesn't everybody do that then? It seems like a very simple thing to implement. So if you think about the algorithm these days, when we talk about reinforcement learning, we talk about the Q of SA, the Q learning, and the Q function is the function that give you the value of each state S and the action A. State being your environment that you're in while you try to make a decision, and A is a decision or an action that you try to decide on. And now we have neural networks, so we use neural network to compute Q of SA to be the best possible being aligned with our overall objective, which might be far in the future. And if you look at the computational complexity of it, it's actually very hard to compute. You have to build whatever model that have a bunch of features and compute the value of it based on that. That just takes a lot of computation. And compared to our baseline of the rule-based system, which is just some if-else statement, just a few lines of code, if you compare that to Q of SA, which takes like hundreds of lines of code to be able to implement that, to learn that properly, and to be able to execute it in a reasonable amount of time. Okay, great, but that's just computer. If you think about it in neuroscience terms, we have this two-system hypothesis, being the first one being the slow, more deliberate one that governed by the cortex, by the neocortex, and the second system being governed by more emotional, more automatic, fast, effortless system. It can be a limbic system, it can be domain-based system. There are two types of decision system in the brain to help you solve this kind of computational problem. So where am I going with this? So as I live my new life here, it turns out that my state, my environment changed a lot. And I try to be intentional with my actions and decisions. And it turns out I have to compute that Q of SA all the time. I have to sit in front of the store, thinking about that product that I just picked up. Like, should I buy that shelf? Should I buy that bin? Should I buy that drawer? And think about it again and again, doing that computation to make sure that it aligns with what I like. It aligns with what I want my life to be. Or it can be small decisions like, do I want to go across town to go to this dinner to meet up with a friend? And that would cost me time, that would cost me money to get there. But compared to a more impulse, more fast system where I say, if I got the invitation and my body seemed to react well with that sound of it, then I go. That's a very compulsive thing. I don't think about things I'm going to get and the cost associated with it. There's nothing around that. I make that kind of decision all the time to make my life be the way I want it to be. And it turns out I spend a lot of energy making such and such decision because it's just so hard to compute the cost, to compute how satisfied you're going to be, to compute how it is aligned with the life that you want your life to be. So it came back to machine learning. So how do I solve this problem? So like each computation does have a cost. So it turns out we never regularize the cost associated with making such and such decision if simplicity is part of your objective function. So I went back to machine learning. So how do we solve this then? So in machine learning, we solve it another way where we have a mixture model. And our brain does have mixture model. We have two systems, right? So it turns out, again, life can be quite complicated and you cannot just rely on one system over the other. You cannot compute Q of SA all the time, or you cannot be impulsive and let your heart just rule most of your decisions. You cannot live like that either. This week is Christmas week. I don't really consider myself a tradition-based person or family person. So my Q of SA said, hey, you don't have to do anything for this Christmas. So one day I came home from work and I just realized that this week is Christmas, and it kind of hit me in a really strange way. I don't know what happened. I just know that something's happening, and I know it's really Christmas, and I have to admit that I do miss it. So that I let that just drive my decision. I'm not sure that's part of intentional living, the lifestyle, the doctrine that we try to subscribe ourselves to, but again, life is more complicated than that, and you cannot compute Q of SA all the time. So John, Merry Christmas, and I'll see you right here in a few days.